Welcome to another video. Let's solve the statistical problem for the rule and the complex root. So if you have to find it, let's say the first one is for the rule, x is a member of real number, and by taking the square of both sides, then we have this as absolute of uh, 3 raised to the power of minus x equals to 3 raised to the power of 2. And this absolute of 3 raised to the power of minus x, so we should know that this is always greater than 0. So for this 3 raised to the power of minus x, so it's greater than 0. And if it is greater than 0, so we are going to know that by turning this, so we have this as 3 raised to the power of minus x equals to 3 raised to the power of 2. And 3 raised to the power of minus x can also be written as 3 raised to the power of x, and replace this as 3 raised to the power of minus 2. Then by cancelling this 3 as the base, since they are equal, we have x equals to negative 2. And here is the real root. So let's see the complex root. Let's see the complex root. Let's see the complex root. And to do that, we are going to consider from some basic rules of Euler. Suppose we have, let's say we have x is a member of complex number in this problem, right? And so if you have to consider this particular Euler, so which says, remember that this exponential can take either positive or the negative values. As this 3 raised to the power of minus s, so if it takes positive or negative value, then so it is equals to 3 raised to the power of 2. And the two sides both are in exponent form, so I can do the replacement. So as I did earlier, that if this 3 raised to the power of minus x becomes 3 raised to the power of 3 raised to the power of x, then this plus of minus here will come here, and this becomes 3 raised to the power of minus 2. Since x is also minus 2, so we can do that replacement here. And we know that if we introduce log of base 3 to both sides, so we have this as the logarithm of so base 3, now why this is plus or minus 3 raised to the power of minus 2. And so this is log of the same, which is 1. We get the value of x equals to logarithm of negative 2 log, because this is the power, so power come down, and we have logarithm of plus or minus 3 base 3. And then I can leave this, or I will consider this law, so by breaking the logarithm and the base. So suppose we have logarithm of a base b, and this is the same thing as log a divided by log b. But I'm not using logarithm again, so I'm using the natural logarithm, so which is ln, so just to beautify the work. So here we have negative 2 ln of plus or minus 3 divided by ln of 3. So we are going to start this, because this is not yet the real solution, because we are looking for the complex, and there's nothing like complex the imaginary value here, which is I. So suppose we have let's say plus or minus 1, so equals to exponential I by n, so that is the Euler. And you know that this n here is a member of integer, whereby the value of x that we are given above is a member of complex number. All right, so x is going to be complex number, since we are looking for the complex part of these equations. Then, so as we have know these two conditions, so let's see, we have ln of plus or minus 3, so this can also be written as ln of 3 dot plus or minus 1. So, and by applying the rules, we have separation of this as ln 3 plus ln plus or minus 1. So we are going to do the replacement. So since this is plus or minus 1, so it's not necessary to write it there. So we have this as ln 3 plus, here is ln plus or minus 1 replaces as exponential I by n. And So exponential and ln, they are inverse. Therefore, we have the ln of 3 plus I pi n. So here is the result for ln of plus or minus 3. Then we come back to where we have the value of x. So we just try to replace ln of plus or minus 3 by what we get below. Then we have x equals to minus 2 ln of. So we are going to create a bracket, and we have this as ln 3 plus I pi n, everything divided by ln of 3. So this is how to get to solve this problem. But I know, so if you have another way of doing this, you can drop it in the comment box. And please subscribe to this channel and like this video. I will see you in the next class. Never stop learning. Bye bye.